All right, so I think we're recording here. Here we have a word problem, and this word problem is a mixture problem. Um, Marge needs a 50% solution of alcohol. How many liters of pure alcohol must she add to 10 liters of 40% alcohol to get the proper solution? And I would like to do this two different methods. And let's give a title to each one of these methods. In the first method, I'm going to call it the bucket method. And in the second, then I'm going to do the same problem again, only call it the seesaw method. All right, so let's do this. Now, I believe that if you were to go on YouTube and you were to search mixture problems, the method that you're going to see the most often is the bucket method. But I don't necessarily know if it's the better of the two methods. The seesaw method, as you will see, um, does appeal to your logic. All right, so let's do this bucket method first. Um, let's draw a picture of what we have. And it's I'm referring to it as the bucket method because I'm going to visualize containers, buckets, holding my solutions. So I've got these two buckets that have uh, solutions in them, and I'm going to add these two buckets together. I'm going to pour the contents into a third bucket for my final result. So it says that Marge needs a 50% alcohol solution. So there's a sticker on the side of this bucket that has the concentration. Um, Marge needs a 50% solution of alcohol. How many liters of pure alcohol? My 50%, my percent is measuring the alcohol content of this liquid. So for the pure alcohol, it's 100%. And in these type of problems, you will sometimes have pure water where you're trying to weaken the solution. And here, what we have um, we have a 40% solution that we're trying to strengthen to 50%. So we're adding pure alcohol to it. The result in both of these methods, it's important to recognize that the result is a concentration that's in the middle between the two starting mixtures. All right, so how many liters of pure alcohol? That's going to be our variable. We're going to let X be the number of liters of pure alcohol. And it says how many liters must be added. We know how many liters we have of this 40% solution. We have 10 liters of it. And if you have X liters and you add 10 liters, then the result is X plus 10 liters. So in this bucket method, we're always going to draw the same picture, and we're always going to label it in the same way, or at least I'm going to. And now we need an equation that models this, and we're going to take the volume times the concentration. So here, if we multiply these two together, we have 100x. Now, sometimes people will move the decimal point over two places, but since you'd have to do that for all three terms, I'm just going to go ahead and drop the percent symbol and write it as an integer. So here I have 40 times 10, and this equals 50 times the quantity x plus 10. So now I have an equation that models our situation, one equation and one unknown, and I'm going to solve for the variable x. So on the left-hand side, I have 100x plus 400. And on the right-hand side, I'm going to distribute the 50 through this binomial, and I have 50x plus 500. So I'm going to take 50x away from each side of this equation, and 100x minus 50x is 50x. And then I'm going to take 400 away from each side, subtract 400 from both sides of this equation, and then divide by 50, and we can see that x equals 2. Now, we don't want to just say that our answer is x equals 2. We need units. Well, the x represented a volume, it represented liters, and it represented liters of pure alcohol. I can't spell very well. My spelling is worse than my mental arithmetic skills. Alcohol. All right, so here is our final answer. Now, let's do the same problem, only by this method that they are referring to as the seesaw method. In the seesaw method, probably the person that came up with this type of solution probably had a physics background, because the idea that we're going to use now is we're going to picture a seesaw, and you can balance a seesaw even if two people get on the, I'm sure you've probably seen a seesaw at a park, and if you have a heavy person and a lighter person, a very light-weighted person, you can balance a seesaw if the light-weighted person is far away from the fulcrum. That gives that light person leverage to balance the heavy person if the heavy person is closer to this fulcrum. So that's the underlying idea in this seesaw method, or at least that's how I take it. All right, so in the seesaw method, in both of these methods, like I say, it was important to recognize that the final solution had a concentration that was in between the other two. So in these problems, you're always going to be able to identify what the weak solution is. So let's call this end of our seesaw the weak solution, and in the middle, our fulcrum is the concentration that's between the weak and the strong. So in this problem, the weak is 40%, the in-between is 50%, and the strong is the pure alcohol, 100%. Okay, now we want the volume of the ones that on the outer here, the volume of the weak and the volume of the strong. Well, the volume of the weak, they told us was 10 liters, and the volume of the strong is what we're trying to figure out, the amount of pure alcohol. So if we think of this seesaw method with our fulcrum, we know that there's the idea of weight times distance is equal to weight times distance. So we need the distance from the difference between these two numbers, and we need the difference between these two numbers. That's our distance. So 50% minus 40% is 10%, and 100% minus 50% is 50%. So we're thinking of that as the distance to the fulcrum. So weight times distance equals weight times distance. even though this is a volume, we're letting the analogy be that it's the weight. So over here I have 10 times 10. And my fulcrum, my balancing point, is equal to, and over here I have 50 times x. And I have one equation and one unknown. I need to solve for x. And 10 times 10 is 100. And 50 times 2 is 100, or divide each side by 50. And then you get x is equal to 2. Now remember, the x was in liters. And it was of the stronger solution, of the pure alcohol. Which is the same answer that we got before. All right, so I hope this helps, and I hope it gives you two ideas to consider. I don't really mind which method you finally decide upon, but if I were you, I would probably pick a method and then be consistent and stick with it. All right, so hey, I hope that helps, and I will talk to you later. Bye.